Good day, learners. Having learned about the ionic and covalent bonds and how they occur and their various characteristics, today I want us to look at chemical structures that result from chemical and covalent bonding. How is it that we draw the chemical representation of the various bonds, or how do we know that a certain bond is chemical or ionic, or how is its orientation? This is where we use what we call as the Lewis dot structures. In the Lewis dot structures, the symbol represents the kernel, that is, the H, the L, the B, the B, and the K represent the kernel, or what we are calling as the name of the atom, while the dots represent the valence electrons, that is, the electrons in the outermost shell. For instance, when we look at hydrogen, hydrogen has got one atom in its valence electron, and it is the only atom it has. Lithium has got one. Sodium has got one, and these are some examples of the group 1 element. Beryllium, on the other hand, has got two, and magnesium has got two and are found in group 2. Boron and aluminium have got three, and they are in group 3. Carbon and silicon have got 4. Nitrogen has got 5, while oxygen and sulfur have got 6. Fluorine and chlorine have got 7. While helium, neon, and argon have got 8. And this is the category we said as the noble gases. They are stable. They have already gained their octet or duet state in the case of helium. So how is it that we represent these in the Lewis dot structure? This is a case of sodium. This is the Lewis structure of sodium, where you see the sodium has lost one of its electrons to become a cation with a positive charge of 1, and it has transferred it to chlorine to get a duet state where it has got a negative charge of 1. But how did we get there? We need to understand how we got there. The procedure to get there requires 3 steps. Number 1 is that after checking that it is ionic, that is, it is a metal, you need to determine which atom will have a positive charge and which one will have a negative charge in case of ionic compounds. That is the first step. You need to identify the position of the metal and the non-metal on the periodic table and understand the subsequent charge it has. For instance, sodium is in group 1 and has got a positive charge of 1, positive 1 in its ionic state. Chloride, on the other hand, is in group 7, and in its ionic state, it has got a negative charge of 1. Step 2, you need to write down the symbols for the first cation with no dots. Remember that we are talking about the cation, as in the case of sodium, is that the cation, you write it like that without dots. The next step is that you need to draw the anion, that is the non-metal, using dots in a diagram, and also complete it with its own ionic status. That is if it is an anion, because it has to be a non-metal, what is its charge? Then complete the outer shell. The last stage is enclose both in brackets, that is the cation and the anion, and show their charge. This is as represented in the previous slide, where we are saying you need to identify the elements you're having, identify their charge based on their position in the periodic table. Once you're done with that, represent the non-metal in dot form. Then after that, close them into bracket and indicate the charge for both the metal and the non-metal. After having learned that, I would like you to, during your free time, to draw the Lewis diagrams of lithium fluoride, magnesium oxide, calcium chloride, and potassium sulfide. Remember, the drill is that you have to look for them from the periodic table to identify how many valence electrons they have in their outermost shell, and what is remaining or what can be transferred so that they can gain their octet or duet state in the case of hydrogen and helium. Then we need to go and look at the Lewis dot structures for molecules, or what we are saying, the compounds that result from covalent bonding. Just as in the case of ionic compounds, the kernel of these elements represent the various atoms, just as was the case in ionic compounds. The dots also represent the valence electrons, just as was the case with ionic compounds. Then another thing to remember is that always the various atoms you're trying to complete or draw their Lewis structure, they are trying to gain an octet state. That is, they are either trying to have 8 electrons in their outermost shell or 2 electrons in the case of hydrogen and helium. For instance, look at this that I have tried, this representation that I've tried to draw here. For hydrogen, it requires 1 electron to get into a stable state. For oxygen, it requires 2 because it already has 6 in its valence. The valence electron is 6. For fluorine, it only requires 1 because it already has 7. For nitrogen, it requires 3 because it has got 5. For chloride, it requires 1 because it already has 7. For carbon, it requires 4 because it only has 4. Then let us look at the case example of methane, which we have said is as a result of covalent compounds. This is how we represent the Lewis dot structure of methane, where we see the carbon here and the 4 hydrogens that are sharing the electrons. But how did we get there? It also has several procedures, just as was the case in ionic compounds. There are 4 steps. Number 1, you have to count the total valence electrons involved. That is, go back to the periodic table and identify a case of carbon. Carbon is in group 4, meaning that it has got 4 electrons and requires 4 more to get an octet state. So after identifying the valence electrons of what is involved, the atom involved, you need to connect the central atom using the first in the formula. You need to connect the central atoms to others using a single bond. That is, in the case of methane, you need to take your carbon and arrange the 4 hydrogens, and in each case put an electron. Then the next step is complete the valence electrons of the outer shell. You need to check, is it that are they 8 already? If not, you need to add the extra electrons to the central atom. That is, it means that you have to increase the bonding from a single to a double or a triple bonding. If the central atom has a valence of 8 electrons surrounding it, then you are done. And I want to show you with an example of methane. Look at methane. The first thing you do is you need to arrange the carbon at the center. Then you orient the other 4 hydrogens around the carbon. Then after that, you need to feed each one of the hydrogens with one electron. So far there will be 4. Meaning that there is a deficiency of another 4. You need to repeat the procedure again. If it is not up to 8, then you need to start doubling and tripling the bonds, as we have seen from the procedure. But Why are we doubling and tripling bonds? It is because sometimes you only have two atoms, so there is no central atom, but it follows the same rule. This is where we have seen for atoms that are identical, like in the case of chloride. When you look at chloride, chloride is between two chloride atoms that have got, each one of them requires one atom so that they can get an octet state, meaning that they have to share the one amongst them between themselves to get to an octet state. The same case for bromide gas, hydrogen gas, oxygen gas, nitrogen gas, and hydrogen chloride. The steps are still the same as what we had discussed in the previous case. But how do we get to a double bond? Atoms that share two electron pairs often form what we call as a double bond. This is in the case of oxygen. Oxygen has got 6 electrons in its valence outermost shell. If it has got 6 electrons, it requires 2 more for it to get to an octet state. If two oxygen atoms are bonding, then it means they have to share 2 electrons for each one of them to get to an octet state. The same case if it is a triple bond, atoms that share 3 pairs of electrons. This is in the case of nitrogen gas. Nitrogen has got 5 electrons in its valence electron and requires 3 more to get to an octet state. Therefore, it has to share with another 3 from another nitrogen atom to get an octet state. Having learned about the Lewis dot structures for both ionic and covalent compounds, please represent the valence electrons for carbon dioxide and ammonia using in the Lewis dot structure. Then draw the Lewis dot structure for examples of polyatomic ions such as ammonia and sulfate. Do not forget what we have said, that you must know the valence electrons that are needed. You need to know when to add and when to subtract, and when to introduce a double or a triple bond. Thank you.